In this video, I'm going to show you how to factor a polynomial where your your front coefficient, does not equal 1. And so on my diagram that I had for you, the flow chart, this is going to be over here in this section. And there are a couple different ways I'm going to show you how to do this. One of them is called split the middle. And then another way of performing split the middle, I'm going to call it borrow payback. And I'll show you both in the same video. So here what it says for split the middle, how to factor, would be very, very similar to our big X method that we did when our A was equal to 1. Except in this case, what goes at the top of your big X is A times C. So your A isn't going to be 1 anymore. And so that number is going to need to alter what your final number C is of your polynomial. B is going to go at the bottom. And then those two numbers that we had been finding when we were taking our big X and doing the big X, those two numbers are just going to be used slightly differently. So for this example down below, where it says find the product of A times C, your A times C in this example here is going to be a 6 times a 10. So the A times a C. So in this big X, we'd have our 60 up top because 6 times 10 gets you 60. Now the B goes at the bottom of our big X, which your B here is 19. What we want to do is find two numbers that multiply to make 60, which is what you see here, and add to make 19. So think of combinations of numbers that multiply to make 60. If you need to make a factor tree off to the side, make sure you do that. So divide by 1, divide by 2, divide by 3, divide by 4, divide by 5, and so on, until you find a factor pairing that between the two numbers will add to make 19. So I'm going to get a couple of these out here. 2 times 30 makes your 60, 3 times 20, 4 times 15, 5 times 12, 6 times 10. You could continue on if you want to make all the factors of 60, but the pairing that we want will be the 5 and the 4, because those will add to make 19 out of the pairings that you found of the factors of 60. So what you're going to do with the 15 and the 4 is not just pop them into your factors like we had before. Instead, split the middle is the name of this method. Your 19 gets turned into those two new middle terms. So instead of having your middle term that was 19, you literally do what's called split the middle into those two numbers that you found over here, the 15 and the 4. You rewrite your trinomial that you originally had, and it now becomes a polynomial, a 4-term, and you do grouping. Hopefully you remember grouping, but I'll give you a quick refresh. The order of which you put these two terms does not matter. I'll repeat that again. The order of how you put your 15x and your 4x, you could even have them swapped, and your answer will not change, but you will do grouping. So in the first two terms here, what do you see that's in common between a 6x squared and a 15x? Pull out what's in common. The GCF here is going to be a 3 and an x. After you pull out the GCF, what would be left would be a 2x, because 6 divided by 3 is 2. X squared, take out an x, would be 1x. My plus sign is going to connect my next term. 15x's divided by 3 and the x would mean I have just 5. And then you're going to do the GCF of the next two terms of your polynomial. So out of your 4x and your 10, the goal is to see, after you pull out the GCF, is a 2x plus 5. These need to be identical factors. Well, 4 divided by 2 will get you 2x. 10 divided by 2 will get you 5, which means grouping worked. So the group that matches is one of your factor pairs. The GCF that you pulled out in the front and the GCF that you pulled out in the back, those come together to make your other factor pair. So this is your split the middle method. It is a combination of your big X and your grouping. Hello? Okay, back to the video. Now, here's another example where I'm going to show you split the middle again, and then I'll show you the next method, borrow payback, in a couple problems here. So what I'm going to do is, like I said before, I'm going to take your A times your C, and this is going to make the top of that big X that we had been using originally. So a 2 times a 5 is going to mean I'm going to use a 10 as my multiplier. My middle number, 11, is the bottom number that we want to find the two factors that multiply to make the top and add to make 11. So name two numbers that multiply to make 10 and they add to make 11. those two numbers would either be 1 times 10 or 2 times 5, and the pairing that's going to add to make 11 is going to be your 1 and 10 combo. Now again, it doesn't matter what order you put your 1 and 10, but you're going to split that middle term into a 1x and a 10x. And again, the order doesn't matter which you want to put those, the grouping will still work. So now the first two terms that you have a 2x squared and a 10x. What would be the GCF from the 2 and the 10? Well, the 2 would be the number. Now the GCF between x squared and an x, you're going to take 1x out. So 2x squared, take away 2x, you'd have just an x. 10x divided by 2x would get you just 5 because your x you took out. Now between 1x and 5, there is nothing in common. In fact, the 1x and the 5 is what I need to match for my original group. So the GCF I'm going to pull out here is just going to be divide by 1. So the groups that match, that makes up one of your factor pairs, an x with a plus 5. And the GCF that you pulled out in the beginning, the 2x, and the 1 GCF from the second half here, those come together to make your other factor pair. And that's your answer for your polynomial here. Here is number 2. 5x squared plus 7x plus 2. Again, I'm going to take a times c. 5 times 2 in this case is going to get me 10. Notice that's the same answer as what we had over here, but this time we want our middle term to add to make 7. So we want to multiply to make 10, add to make 7. This time I'm going to pick that 2 and 5 combo. Now again, it doesn't matter where you put your 2 and your 5. You just plug in a 2x, you plug in a 5x. So your split, your middle, the 7x, is going to come from those two numbers, 2 and 5, that multiply to get you 10, but add to get you 7. So the 2 and the 5, now we're going to split our 7x into a 2x and a 5x. Again, order of how you put these will not matter. So then what you do is you take the GCF now, because now we have 4 terms. We're going to do grouping. You take the GCF of the first 2 terms. What these two have in common is just that they both have an x. 5x has 2 of them, but this one only has 1 that we can take away. So 5x squared, if I take away an x, I'm left with 5x. The 2x term, I'm taking the x out, so I'm just left with a 2. Now a 5x and a 2, notice that's what those two terms are, what I needed, a 5x and a 2, to have my matching group here for factoring by grouping to work. So I'm going to just divide as a GCF from these two terms 1, because 5 and 2 have nothing in common but a factor of 1. So the factor pair that matched identically, that is one of your factor answers. The GCF that you pulled out in the front, the GCF that you pulled out in the back half here is going to come together to make your other factor pair answers. Okay, now I've shown you a couple of these where you had split the middle. I want to show you another method that might be more useful to you, just if it makes more sense to you. So I'm going to do like 3 of the next examples with my next method, which is called borrow and payback. It's very similar to this. We're still going to use this idea like your big X kind of idea, okay? So I call it in this case borrowing your 2. I'm going to borrow the 2 from the front term because it's harder to factor when that 2 is in the front. So I'm going to essentially borrow the 2 away. And I'm going to borrow the 2 and attach it to the 9 here, just like we said, multiply your a and c together. So I'm going to multiply my 2 by 9. So I'm going to have 1x squared now plus 19x, and I'm borrowing that 2 to go in the back here. 2 times 9 is going to get me 18. Now this is like one of the factoring types that we did before. When your a is equal to 1, it really is as simple as tell me 2 numbers that multiply to make 18 and add to make 19. I bet you can come up with those 2 numbers. What are the 2 numbers that multiply to make 18 and they add to make 19? Well, it's going to be an 18 and a 1. Now, if our a had originally been 1, we would be done here. But when your a is not 1, it's not as simple. Remember how I said you borrowed a 2? Now, this is where you have to remember to, when you borrow something, you got to pay it back. And this is how you pay it back. I write that number down so I know what number I'm supposed to return. You're going to pay it back. You borrowed it by a multiplication, so you're going to return it by dividing. Now, this is what's going to happen. Think about this as like you would a fraction. Does 18 divide by 2 and get a whole number? If it does, then that's just your number that you're going to plug in here. 18 does divide by 2, you get a 9. But 1 does not divide by 2 evenly to get you a whole number. And so to fix that, what we're going to do, and this is how you're going to factor it every time, you're going to bump that 2 just right in front of your x, and it becomes a 2x plus 1. And that is how you're going to factor a 2x squared, a 19x, and a 9. So just kind of as a check, I'm going to check my work. X times 2x is going to get me 2x squared. X times 1 is going to get me a single x. 9 times 2x is going to get me 18x, and a 9 times 1 gets me 9. Do these two terms add up to be the 19 that you needed? Yes, they do. Your 2x matches, your 19x matches, and your 9 matches as well. Okay, let me show you that one again a couple times here. So in this case, I'm going to also borrow a 2. So I'm going to have 1x squared plus 5x, but I'm borrowing that 2 over here like we would multiply our a and c like we did up here. Okay, negative 25 times 2 is going to turn this into a negative 50. Now we're going to factor it like we would when a was 1. What two numbers multiply to make negative 50 and add to make 5? I'll say that one more time. Find two numbers that multiply to make negative 50. Well, one has to be a plus and one has to be a minus to multiply to make a negative. To add to make 5, your larger number needs to be positive. I'm going to go with a 10 and a 5 multiply to make 50. 10, positive 10 minus 5 will get you 5 for your middle term. But I borrowed a 2. And you have to remember with borrow payback, you have to pay back that 2 that you borrowed. You borrowed it by multiplying, so you're going to pay it back by dividing. Does a 10 divide by 2 evenly? If so, then you write that number down. You get x plus 5. But if this doesn't reduce into a whole number, what you're going to do is bump that number out in the front of your x. So you have a 2x, a 2 in front of your x, and then that minus 5 will stay. And that's your factor answers. Pick which method works for you. Again, you can do split the middle. You could do borrow payback. You could even do guess and check. It's not my favorite method, but you could totally do guess and check. I'm going to show you borrow payback one more time here. And then I'm going to show you one that includes a GCF and then borrow payback. Okay, I'm going to borrow this time. I'm going to borrow the 3 over here. So I'm going to have 1x squared now instead, minus 8x, and minus 3 times 35. This is make negative 105. Now the goal is to find here, like what we did here, is two numbers that multiply to make negative 105 and add to make negative 8. Well, if it's going to multiply to make a negative, I'm going to need one positive and one negative number. So I'm going to start checking some numbers on my calculator here. Okay, so I need 105. I need to divide by a couple numbers, and their difference needs to be negative 8. I'm going to try dividing by 5. Does a 5 and a 21, can they be combined to make an 8, like 21 minus 5? No, so I'm going to try a different pair. How about let's go with a 15. A 15 and a 7 are 8 units apart. If my 15 is negative and my 7 is a positive, they will add together to make negative 8. Okay, now I borrowed some money, I was going to say. I got to remember to pay it back. 7 does not divide by 3 evenly, and so what you're going to do is just bump that number 3 right in front of your x. That's going to be the coefficient now. 15 does divide by 3, and you get a 5. So I'm just going to multiply here and confirm that we factored correctly. 3x times an x will get me a 3x squared. 3x times negative 5 will be negative 15x. 7 times x will be a 7x. 7 times negative 5 would be negative 35. Do these two terms work out to be the 2 that I needed them to? I have 3x squared. This will make negative 8x and minus 35. I checked my work by multiplying just to confirm. All right, now I want to do one where you have a GCF and what we've been doing here. I noticed that all of these terms are even, so I'm going to divide first by the GCF of all of my terms by 2. So GCF, I'm going to pull out of all my terms, which is going to be 2. 6x squared divided by 2 would get me 3x squared. Negative 2x divided by 2 would be just negative 1x. 8 divided by 2 would make this last term a 4. So kind of like what we have here, but my GCF needs to stay a part of my answer. We're just going to see a 2 show up out front, like out of my factors that you see here. Again, I'm going to do borrow payback. I'm going to borrow the 3 here. So I'm going to turn this into x squared minus an x minus instead. 4 times 3 will get me 12. What two numbers will multiply to make 12? Negative 12. That means I'm going to need a plus and a minus. And those same two numbers are going to add to make negative 1. I'm going to go with a 4 and 3. 4 and 3 will multiply to make 12. Which one do I want positive or negative here so that their sum makes a negative? Well, if the sum is a negative, the larger one is going to need to be negative. Here's the thing. I notice as a teacher now, I've done this long enough, you got to remember to pay the 3 back. Don't stop here. You borrowed 3, you have to pay it back. And that's probably where I see the most mistakes, is you got to pay that back, okay? The 2 stays out front, that's your GCF. 3 does divide by 3 nicely. That's going to turn into a 1 when you divide. Think about it like a fraction. 4 divided by 3 does not reduce to be a whole number, so that 3 is just going to bump right in front of your x. And that is how you factor a not 1 and a GCF. There's a couple more problems. I want you to give them a go on your own. Check the answer key on Canvas if you have questions. And then I want to end with one word problem here. I'll do one, and then I'm going to let you try the other one on your own, okay? Area of a rectangle. This one's going to be area of a square. So I'm going to get you started at least with the picture here. Rectangles have opposite sides that are equal in size, but these sides, because of a rectangle, will not be the same as those sides. Versus with a square, all 4 sides are going to be the same. It tells you the area of the polynomial, so you know what the area is, and we're going to try to find the length and width that made that area happen. Area of a rectangle is your length times your width. So I know that 12x squared, this is my area, plus 13x minus 90 is going to be equal to a length times a width. And they give you one of the dimensions. They give you a 3x and they give you a 10. Now, what would you need to multiply 3x by to get your 12x squared? What would these two first terms need to, you need to multiply by 3x by to get 12x squared? You'd need to multiply by a 4x. Okay, that's going to be that dimension. Now, the last term, 10 times what number over here? 10 times what number is going to get you negative 90? That's going to be negative 9. Now, you're going to ask me, well, hold up. How do you get the 13 middle? This is how you get the middle. The 3x times your negative 9 would be negative 27x. The 10 times the 4x is going to get you 40x. These two will combine to make your 13x middle. Now over here with the square, area is going to be your length times width, but these are going to be the same size because it's a square. So area of a square actually looks more like this. It's a side, one of the sides squared. So your two dimensions here need to be identical, unlike how they were not identical for your rectangle. So 4x squared plus 28x plus 49. This is called a perfect square trinomial because these two dimensions are going to be the same size. So think about square roots. What's the square root of 4x squared? What times itself would make 4x squared? It has to be a 2x. What times itself is going to get you 49? It has to be 7. Now, again, how are you going to get the 28 middle term? It's when you multiply them out. 2x plus 7 times a 2x plus 7. Your outside is going to make a 14x. Your inside is going to make a 14x. And together, does it make the 28 that you needed? It will. So here's your side. A 2x plus 7. And the side that was missing over here was a 4x minus 9.